Welcome class 10. Today we start with chapter number 4, Refraction of Light at Plane Surfaces, and today's topic is refraction. Suppose let's say that a ray of light is traveling in a medium and it strikes at the surface of another transparent medium such that a portion of this light gets reflected in the same medium following the laws of reflection, and thus it is called the reflected light, and the remaining part of this light enters into the other medium and travels in a straight path but in a direction different from its initial direction, and this uh, and this ray is called the refracted ray. So we can define this bending of light as the change in the direction of the path of light when it passes from one transparent medium to another medium, and this change is called refraction. So here light suffers partial reflection. As you can see, a small portion of the light is reflected out here and a small portion of light gets refracted in this direction. So here there are few terms like this is the incident ray. When it strikes the surface, before it is called incident ray. Then after it gets reflected, it is called the reflected ray. Then this is the normal, which is perpendicular to the surface. All right, this is 90° to the surface. Then this ray after refraction is called the refracted ray. Then this is called the angle of incidence. The angle between this incident ray and the normal is called the angle of incidence. The angle between the refracted ray and the normal is called the angle of refraction, represented by small r. Then this is the boundary surface between the two media, okay, either air and water or maybe air and glass and so on. And this is the dotted line represents the actual path of the light that the light is supposed to travel in, okay, but after striking the surface it bends away from the actual path. Either it moves towards the normal or away from the normal. Rarer and denser medium. Light travels in different medium with different speeds. In some medium its speed is fast, whereas in some medium its speed is slow. So rarer medium is the medium in which the substance in which the light travels faster is called the rarer medium. So the substances in which light has more speed, or if its speed increases, is called optically rarer medium, like for example air, vacuum, etc. So here the speed of the light is maximum. Similarly, we have denser medium. Denser medium are those substances in which the light travels slower. So when the speed of the light is decreased in the medium, then these mediums are called denser medium. For example, water, glass, etc. Now, when light travels from a rarer medium to denser medium, what happens? Suppose the light is traveling in one of the medium, let's say in air, and it strikes the surface of glass. Now compared to air and glass, in comparison to air and glass, glass is optically more denser and air is optically rarer. This means that light travels faster in air compared to glass. So here again, a portion of the light will be reflected into air itself, and the portion of the light which is supposed to move in this direction will get refracted, and it will move towards the normal. Towards the normal if it moves from rarer to denser. So always remember, when the light travels from rarer to denser medium, the light bends towards the normal. So here this is the angle of incidence and this is the angle of refraction. So when light travels from rarer medium to denser medium, the angle of incidence is greater than angle of refraction. And the difference in the angle of refraction and the actual path, this line, this angle is represented by delta, which means it is deviation. Deviation simply means angle through which the ray turns. So deviation is equal to angle of incidence minus angle of refraction, or simply the difference between angle of incidence and angle of refraction. Next, when light travels from a denser medium to rarer medium. Here let's assume that the light is traveling in glass, which is denser medium, and it strikes at the surface, and here the outer surface, the outer medium outside the glass is air. So here, after the light is incident in the surface, it goes through the reflection, it undergoes reflection. A portion of light is reflected back into glass, into the same medium, and a portion of light which is supposed to move in this path, in the dotted line, will now bend and move away from the normal. So here, when the light enters from denser to rarer medium, denser medium is glass and rarer is air, it moves away from the normal. So this is the normal, it moves away from the normal. So this gap between the normal and the refracted ray is increased. So we can remember that denser to rarer medium, the light always bends away from the normal. Again here, the angle of incidence and the angle of refraction, if you see, the angle of refraction is more than angle of incidence. And the angle of deviation is given by angle of refraction minus angle of incidence. Next, when the light travels normally on the surface, for example, if there is a boundary between the two media, air and glass, air is optically rarer and glass is optically denser medium, and suppose if there is a normal, that means the line is perpendicular to the surface and the incident ray is normal, that means incident ray is perpendicular to the surface or the boundary surface between the two media, then the light will refract without bending. So here the angle of incidence is equal to 0 degree. That means there is no angle formed between the angle of incidence and the normal. That is 0 degree. And the angle of refraction is also equal to 0 degree. So here we can see that there is no deviation, or we can say the deviation is equal to 0. But when the light travels from one medium to another without bending, that is when the light is perpendicular to the surface, then its speed will change even though there is no bending of the ray. Next is cause of refraction. When a ray of light travels from one medium to another, its speed changes. So if the light slows down, then it bends towards the normal, and if the light speeds up, then it bends away from the normal. And while passing from one medium to another, if the light does not change its speed, then it does not bend. It passes undeviated. while passing from one medium to another normally, that is perpendicularly, if the light does not bend, then it changes the speed. Next is laws of refraction. This is the picture of Willibrord Snell, who was born on 13th June 1580, died on 30th October 1626. Willibrord Snell was a Dutch astronomer and mathematician who discovered the law of refraction. And the law of refraction is also known as Snell's law. So let's look at the first law of refraction, which says the incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane. So here I have tried to make the image in 3D form. So here is the incident ray, and this is the refracted ray as well as the reflected ray, and this is the surface, the boundary surface between the two media, and this is the normal. All these lines and rays and the normal lie in the same plane. That means if you pass a plane through these lines, then all will lie in the same plane. None of the rays or lines will be coming out of the plane or going inside the plane. That means all of these lines lie at the same plane. Next is the ratio of the sine of the angle of incidence I to the sine of the angle of refraction R is constant for the pair of given media. This means mathematically we can write sine I by sine R, that is sine of angle of incidence by sine of angle of refraction, is equal to mu. This is a Greek letter named as mu, which is a constant. So this constant mu is called the refractive index of the medium. So what is refractive index then? Refractive index of the medium is defined as the ratio of the sine of angle of incidence to the sine of angle of refraction. And the unit of refractive index is, since it's a ratio, sine I and sine R, it's the ratio of the same quantities. Therefore, the units are cancelled. So it has no unit.